All right, class, so this is an ALEKS topic called identifying acids and bases by their reaction with water. And this is a pretty good basic type of question. It's going to ask us to sort of go through a lot of different compounds, which I think is really good. And this is something that's going to be really helpful for us as we move forward through this class. So in the first thing that I would encourage you guys to do is to ignore this column. Just let's first do ionic or molecular. You might start confusing yourself once you get into this other part. So the first thing, just ignore everything else and just think about ionic or molecular based on all the stuff that we've talked about before. So again, ignoring everything else, if I see sodium nitrate, I'm going to see a metal. Sodium is a metal. And I'm going to see a polyatomic ion nitrate. To me, that clearly indicates an ionic compound. So that's what I'm going to say there. The next one, HNO3. So hydrogen is not a metal. It does show up on the left-hand side of the periodic table, but it is not a metal. So technically speaking, this HNO3, this is going to be a molecular compound. So previously to 163 or your General Chemistry 3 course, you would have always considered this to be a molecular compound. We're going to find out later it behaves like an ionic compound a little bit, right? It's going to be a strong acid. But for now, when we're doing this type of identification, we're still going to call that molecular just because there's no metal, right? If there's no metal, it can't be an ionic compound. So this next one, again, these are all nonmetals, CH3, NH2, those are all nonmetals. That looks like a molecular compound to me. And then the last one here, barium hydroxide. Again, barium is an ion, it's a metal, so this should be an ionic compound. So I've got barium as a metal, and then OH minus is my polyatomic anion. Now let's go through and do the strong acid, strong base, weak base thing. So this first one, I'm not noticing anything that would indicate an acid or a base. I don't see any H+, I don't see any H3O+, I don't see any OH minus. This is just an ionic compound, so that's all I'm going to put there. For the next one, now I'm seeing H3O+. So I'm seeing this H3O+, NO3 minus, and this sort of suggests, right, I've got water as well because it's aqueous. This suggests that all of this HNO3 is dissociating. So if I put one HNO3 in, it's completely dissociating to H+ and NO3 minus. That indicates a strong acid. So this is going to be a strong acid. The next one, CH3NH2, when we're starting to see this NH2 motif, it's going to be something that we see again and again and again. That should indicate base to you. A really common type of organic base is going to be nitrogen with a lone pair of electrons. So this CH3NH2, this nitrogen would have a lone pair of electrons. That lone pair of electrons can accept H+, so it can act as a base, and that's what we're seeing here. CH3NH3+, that indicates that I have accepted H+. I'm going to be forming OH minus, so that indicates it's a base of some form. Now, in terms of strong or weak, I also see that in my solution, I'm going to have CH3NH2. I'm going to have the same compound that's still present in that water solution. So if the same compound, if not all of it reacts, if not all of it dissociates, or if not all of it accepts an H+, then that indicates it's going to be a weak base. So this would be an example of a weak base. Now, this last one, barium hydroxide, here again, we're completely dissociating. All of that barium hydroxide is turning into Ba2+ and OH minus. So this indicates that this is going to be a strong base. It completely dissociates into those two different portions. So that indicates it's a strong base. I do not see any of this BaOH2 intact in my water solution. Let's do one more. So here again, the first thing that I would do is run through ionic or molecular, and again, ignoring everything else. So if we just look at HC2, H3O2, all nonmetals, all of those are nonmetals, that's got to be a molecular compound. C2H5 NH2, again, all nonmetals, got to be a molecular compound. I don't see any metals, it can't be ionic. Simple as that. KCl, K is a metal, potassium is a metal, Cl is a nonmetal. This indicates an ionic compound. HCl, again, this is one that you might get tricked by, right? This is one that you have to be careful about. Hydrogen is a non-metal. It does show up on the left-hand side, but it is technically a non-metal. And even though it's going to behave very similar to this KCl, this is a molecular compound. This is not a metal. Hydrogen is not a metal, so it's not technically going to be an ionic compound. So we are going to still show this as a molecular compound. Now let's get into the rest of this treatment. So here, HC2H3O2, I'm seeing some H3O+, tells me that it's an acid of some sort. I got H+ dissociation. C2H3O2-, that's the conjugate base of this weak acid. And then I also see some of that weak acid still intact, right? What that's suggesting is that HC2H3O2, when you put it into water, some of it stays together. It's moving around in the solution together. And then every once in a while, they will dissociate, right? A little bit will dissociate, but mostly they're actually going to be intact together. So that's going to be a weak acid. The next one, this is going to be, again, this nitrogen lone pair of electrons. That's going to be an indicator of a base, right? And I can see I'm accepting H plus here to form this C2H5 NH3 plus. That means that I've accepted H plus from water, forming OH minus, indicates a base. Some of it's left over though. It's not all reacting. It's not all, every time I put one of these in, it's not taking H plus. So that indicates it's a weak base. It's got some, but it's not got all, essentially. This last one, KCl, this is just an ionic compound. I don't see any H plus, I don't see any OH minus, just an ionic compound. We're going to leave it at that. And then HCl, this is a strong acid. It's pretty typical strong acid. I would hope that we would recognize that. So H3O plus, so that's the H plus, Cl minus, it's completely dissociated into its different pieces, H plus and Cl minus. And then we're forming that H3O plus from the water. So again, don't be tricked by this last one, right? It's a strong acid, but it's still a molecular compound, even though it's sort of behaving in that more ionic way.